Welcome to another one of my videos. This is the second question on instrumental analysis that I have recorded. I've taken this paper from a past IB paper. This time we need to identify ion X from its empirical formula, infrared spectrum, and mass spectrum. Before we do that, the question also asks us to explain why X cannot be propped 2 in 1 all, and there are 3 reasons why. First, there is no C double bond C peak at 1620 to 1680 wave numbers. Secondly, there is no OH peak at 3200 to 3600 wave numbers, which indicates the hydrogen bonding in alcohols. And thirdly, there is a C double bond O peak at 700 to 750 wave numbers. So let's take a look at the spectrum again. We are missing C double bond C peak and OH peaks, but we have a prominent C double bond O peak at 1750 wave numbers. Moving on, to identify X, we need to find out if the C double bond O group belongs to a carboxylic acid or either a ketone or aldehyde. Well, we're missing a carboxylic acid peak, so X must be either a ketone or an aldehyde. Next, we are told that there are 3 peaks in the proton NMR. This tells us that there are only 3 hydrogen environments, so the empirical formula could well be the molecular formula. Let's find out if that works. First, draw out all the ketone and aldehyde isomers of C3H6O. And then we have to analyze each of these isomers for the proton NMR signals. The first isomer here has a line of symmetry, so the hydrogens on either sides have exactly the same environment. This results in only one signal, and we expect the signal to show up at 2.2 to 2.7 ppm. This isomer cannot be X. The second isomer has 3 different hydrogen environments, resulting in 3 different signals. The yellow hydrogens are quite shielded, as it is far from an electron withdrawing group. Thus, it shows up field at 0.9 to 1 ppm. The blue hydrogens are next to a carbonyl group. They are more de-shielded than the yellow hydrogens, and the signal shows up at 2.2 to 2.7 ppm. Whereas the green hydrogen is on the carbonyl group, and it experiences the strong withdrawing effect from the carbonyl group, and therefore is very de-shielded, and the signal appears downfield at 9.4 to 10 ppm. We can now conclude that X is propanol, as it is an aldehyde with 3 peaks on its proton NMR.
You did great! Leave a message if you have further questions or suggestions. Please like, subscribe, and share if this video has been useful to you. Thank you!